Good morning, everybody, and welcome to our web chat on the impact of ultra-high-density grazing practices. We're still expecting many more people, so we'll give it another minute or so. But in the meantime, you're welcome to drop your name and where you're from in the chat box so that we can get an overview of whether our attendance is mostly from the agricultural sector or the mining sector, etc. So let's give it a minute or two, and then I'll do an introduction for Frits, and then he can start with his presentation. Thank you very much.
All right, good morning, everyone. Good to see so many people attending this webinar. And yeah, I'm delighted about that. Apparently, it's the webinar that LaRSSA hosts that has the most booking so far. So we're very glad about that, and we appreciate your attendance. So yeah, today I'm going to talk about a long-term study that started in 2019. So let me just put up my presentation. All right, yeah. So the study has been done by myself. I'm the lead, let's say, data collector. And it was initiated by, among others, Danie Slabbert. And so let's start with the presentation. We've decided that we would take questions afterwards. We deliberated whether we should have questions in between, but I think it's better that we have it afterwards. So please keep your questions, and then after we can start with the questions. Glad to see quite a number of my friends and colleagues also attend this webinar. Some of you have more insights and have even read the report that culminated from the study so far. So it is a long-term study, and we're planning on doing again surveys early next year. And we also planning on extending the study to other bioregions in South Africa. So just for an introduction, I think we all agree that the pivotal role of grazing management on rangeland health is widely acknowledged. We all know overgrazing can be devastated in terms of ecosystem health and grazing capacity and natural capital in the broader sense. So non-selective grazing, with all the other names, I'll share some of the other names as well, was pioneered in South Africa at least by Acox when he published his first article, semi-scientific article on non-selective grazing as a means of restoration. And although Acox was very convinced this is the way forward to restore natural rangelands, he had quite a bit of slack from the Department of Agriculture, and they actually barred him from discussing his ideas with farmers on the stage. But later on, of course, it was further extended and popularized by Alan Savory. We all know Johan Zietsman's big role in promoting high-density grazing. Also, Lund, who was a farmer in close to Fort Beaufort, or Beaufort West, and then many others, of course. And it has emerged as quite a popular approach for improving rangeland ecology, of course, not without any controversy. There are many names for, let's call it non-selective grazing. In this study, I use non-selective grazing as the main term, although I think we all know it's never completely non-selective. There's always a form of selective grazing involved, even at very high densities. But other terms used is high-density grazing or ultra-high-density grazing, regenerative grazing management, adaptive multi-paddock grazing, mop grazing, short duration rotational grazing, holistic plant grazing, and I think the list goes on. Basically, the aims of non-selective grazing is to increase stocking density while also enhancing rangeland ecology. And the fundamental principles of non-selective grazing is based on historical large herbivore migration patterns, known as the herd effect or herd impact. And of course, simulating the role of predators also play a very important role in non-selective grazing. Of course, even migration of large herbivores, the density of those herds varies a lot and is mainly or a lot based on how much biomass available for consumption by the animals is. So in other words, your dry environments will have less dense herds, and your higher rainfall regions typically will have large and more dense herds during migrations, which might vary over spatial areas as well. Despite limited research and quite a bit of contesting results, if you look at the literature at the moment available, non-selective grazing is widely adopted by especially cattle farmers. So there is a bit of a thing whether high density grazing or non-selective grazing is overly hyped up, and therefore farmers adapting it at the moment, and whether it really and truly have improving results if it comes to ecological functions and so on. So in this context of limited research available at the moment, we started a project, a long-term research project on Danie Slabbert's farm in 2019. We more or less collected data every second year. We're going to collect early next year as well. And so this is an ongoing study. But I would like to share our results of the study so far. The last data was collected in early last year, 2024, January. The study includes basically two studies. The one is the ongoing long-term research study, where we look at the impact or the changes, especially in grass species composition on Danie's farm between 2019 and 2024. And the second part of the study is where we compare the non-selective grazing with selective grazing. So we compare two extreme grazing management approaches. And we're really lucky in the sense that we have two farms right next to each other. You can basically cross the fence, and then exactly in the same landscape, you have a different grazing management approach. So on both these farms, we look at the grass species composition, and we mainly use the last surveys for comparison. We also look at forb species. We look at grass biomass production, and we also look at water infiltration. Unfortunately, we're not looking at soil yet, but that's going to be included from next year onwards, and also on other farms that we're going to include in the study. So we are interested in seeing if there are any differences in maybe organic carbon and soil life and fertility and things like that. So where is this farm or the study area located? It's on the farm named Van Rooyen's Woning, which is near the town of Reitz in the Eastern Free State. And let me just... And it does fall in the grassland biome, especially the so-called Veld grassland biome. And in this area specifically, or mainly for the Veld, there's a huge differentiation between the most palatable grasses and the most unpalatable grasses. So you can just imagine selective grazing and managing selective grazing becomes quite a challenge. The rainfall is 665 millimeters per annum, long term. And it's, of course, mainly summer rainfall. It's quite high. It's 1,700 meters above sea level. And the farm is Danie Slabbert. And he's using non-selective grazing. He's using strip grazing under quite a high density. I'll share now what the density is. So we can definitely call it ultra-high density grazing. All right, so on Danie's farm, there are plus minus 500 cows in the herd, and he uses 100-meter wide electrified strips in which he moves the animals per hour, and the animals move more or less, depending on how much biomass available, but more or less on average 10 meters per hour. And he starts at 7 a.m. in the morning and he stops at 6 in the afternoon. During the evenings, he would open a larger area and animals can relax a bit. So effectively, he only grazed one particular area per year, although in the last 2 years, he has followed the main cow herd with heifers. About a month or 6 weeks after the main herd moves through, the heifers will follow in the same area. So the whole idea is so that the heifers can have higher quality grazing because of the 6 weeks regrowth that follows the main herd. The animal density, if you calculate it per year, for that 500 cows per 1,000 square meters, basically, comes down to 5,000 LSUs or Drakensberger cows per hectare per year, which is definitely will fall under ultra high density grazing, maybe even ultra high density grazing. So, and that comes down to 1.2 hectares per livestock unit per year. So that's quite a high stocking rate. And admittedly, before Danie started and took over from his dad, there was quite a high level of selective grazing or selective overgrazing coming present. So, and he started in 2017 with his ultra density grazing. We started collecting our first data in 2019. During the winter, the animals are going to the croplands where he also plants cover crops for extra feed for the animals. So then we compared to his neighbor's farm, and he has a 2-camp system, and animals will rotate between the 2 camps on the monthly rotation. And on that farm, the farmer is more or less on 4 hectares per livestock unit per year, or throughout the year. And that's also the regional grazing capacity norm as set by the Department of Agriculture. So we have these two extreme systems, which is maybe not always fair. It might have been better, or it might also be good to include a more, let's say, conventional rotational grazing system as a control. So these two extremes will highlight the results a little bit better than if we used conventional grazing, but such a farm was not available. So this drone photo just illustrates what the layout looks like. You can see the 100-meter wide strips, and then the animals move within these strips every hour 10 meters on average forwards within the strip. At the back is the water, so no fence is at the back. It's just the front fence that's moved upwards every hour, and you use electric gates to do that. So it's not very labor intensive. They set these electric gates early in the morning, and then the animals would move on automatically through the use of those electrified gates. I'll share later on how these gates work if you're interested. So then the control system is a two-camp system, as mentioned, where animals alternately graze one month, and then they come back. And then it promotes quite a high level of selective grazing, specifically in the sour velds where we are. And then the stocking density is based on the norm, governmental norm, which is 4 hectares per livestock unit. Just a simple graphic illustration, 1 month in, 1 month out, 1 month in, 1 month out. All right, just a bit of environmental features at the study area. It has quite an undulating topography. The soils are sandy to sandy loams. They are marginal for cropping, as most of the grazing in that area is, and the high potential soils are used for cropping. Warm temperate climatic region, which has cold dry winters and warm wet summers. Frost very common, that part of the world. Rainfall 665 millimeters per annum, although that can vary, of course. And it seems it varies more in recent days per year, and even more erratic within each month. And the grazing capacity is 4 hectares per livestock unit per year. Natural vegetation, it falls in the grassland biome, falls in the Messick Highveld grassland bioregion, and the vegetation type there is the Eastern Cape, the Eastern Free State clay grassland, which normally has quite a bit of clay, but at our study site it's a more sandy soil. So we have 8 sites on the 4 on the one farm and 4 sites on the other farm. And we've located these sites that they represent various areas within the landscape. So on each farm, there's a site on the crests. There are 2 sites on each farm located on slopes, and 1 site on each farm located in the valley bottoms. We collected data for grass species composition by using line transects, 100-meter line transects using extractable 100-meter tape line, and collecting at 1 meter intervals the nearest grass species. And we used the benchmark method using two two sets of values, the ecological status of the grass and the values and the grazing value of a grass from 1 to 10, to analyze the Veld condition score, the VCS, and then eventually also to determine the estimated grazing capacity. And then we also collected grass biomass data with a disc pasture meter at 1 meter intervals on the same 100-meter transect. And we used actually, there are two sour grassland equations that we use to obtain the biomass production per hectare. We use the average of those two equations. And then we use the biomass method of Moore and Woodendal for estimating grazing capacity based on biomass. And within that equation, of course, there's a utilization factor. And we use the Rangeland, the VCS, for which, of course, represent the quality of the grazing within that biomass method equation. For composition and density was determined using 1 by 1 meter quadrats at 25-meter intervals along the same 100-meter transect, as you can see in the illustration at the bottom. So 5 quadrats were used per transect. Within each of those quadrats, the specific forb species were identified and the number of individual plants were recorded. We also, only during the last surveys, we also measured the water infiltration capacity by using a single ring infiltrometer. And we collected data also at 25-meter intervals along the same transect. And then for botanical diversity, including the grass species and the forb species, we used the Shannon Diversity Index, which of course focus more on richness and evenness, and the Simpson's Diversity Index, which focuses more on individual species abundance. And we average those two indexes to get an idea of what the herbaceous species diversity is on the farms, on the two sites. All right, for the ecological status or ecological index, we group the grasses according to the groups that you can see on the slide there, the decreases, increaser ones. So decreases, of course, all your good grazing grasses. And when we do surveys and long-term monitoring, of course, we focus a lot on the decreases. We would like to see them increasing, of course, over time, because that represents then an increase in the grazing capacity and the quality of the grazing. So, and then the increaser ones are the grasses that increase during underutilization or in combination with fire, of course, because the less fire they can also increase. And then for increaser twos, we split them into two, increaser 2As and Bs. So 2As basically would mainly be your subclimax grasses. So let's say they weekly perennial grasses. And then the increaser Bs would be mainly your pioneer grasses. Both of these, of course, increase during overgrazing. And then in that particular part of the world, increaser threes play an important role. In your dry parts, maybe not so much. But increaser threes are strongly perennial, highly unpalatable grasses that increase during selective overgrazing. So that was the last group that was considered with ecological status and our calculations for Veld condition scores. All right, this slide just shows you a breakdown of the different sites. So there are 8 sites, 2 in the non-selective grazing study portion and 2 at the selective grazing study portion. So there you can just see the site numbers that we use. That's not really of interest. And where these sites are located, I'll show you a satellite image now where they are. And then just, I think it's always important to remember what the stocking density is. So the non-selective grazing sites are exposed to a much higher stocking density than the selective grazing sites. So this slide shows you the different sites and where they are located in the terrain, and also shows you the contours, that you just get an idea of what the slope there is. So the sites on the right-hand side, on the eastern sides, are those exposed to high-density grazing, and the ones on the left-hand side or left bottom side are the ones in the selective grazing area. So in the selective grazing, non-selective grazing on the top right, number 2 and 4 are on slopes, and number 5 are more or less on the crest, and number 6 is within the valley bottom. And then on the selective grazing, the bottom left, number 8 would be on the crest, and number 1 and 7 more or less on slopes, and number 9 right down in the left corner, bottom left corner, is the site in the valley bottom for the selective grazing sites. Right, these photos just give you an idea of what the vegetation structure at each of the 2 study areas is. So you can see the photos that you see here are all taken at the non-selective grazing sites. And you can see quite a bit of biomass, relatively even structure, quite a bit of forbs in some of those. And yeah, so, and then if we compare that with the selective grazing sites, you can clearly see the level of selective grazing here. So you can see it has quite a bit of what we call grazing lawns, which I suppose makes sense if you graze every second month on a rotation, and then interspersed by very unpalatable grasses. So the grass that you can see with a big tuft there is Aristida junciformis, which is well known to increase during selective overgrazing. And but those grazing lawns are quite stable, and they remain the size. They might even increase over time. We haven't seen that, but they may, on the very long term, they might increase in size. And at the valley bottom, it looks a bit different grasses available there, more your wetland grasses growing there, and you don't see the same level. You can see still when you walk there, you can see selective grazing, but with a different effect. All right, so we're going to start with the results now, and we're going to start with the long-term study results on the non-selective grazing part, or ultra-high density grazing part, from 2019 to 2024. So that's a 5-year study period so far. So I'm going to go through these results starting from the top. So and we're going to start looking at the C3, or the winter active, or the cool season active grasses. So first start with the percentage within the overall composition. So what's interesting is that these grasses has really increased in number and in species, in composition and in species. So 2019 we started with 1% C3 grasses, and after 5 years, we ended with 13.8% of these species within the overall composition, which was very interesting. And I get similar reports from farmers that, especially in the Eastern Cape, that they see these C3 grasses increasing over time, which of course is a good thing because they provide green grazing during autumn and spring. And so you have a bit of extension in your grazing season if it comes to quality grazing. And yes, C3 is also increased in the number of species. 2019, we recorded 3 species. And in 2024, we recorded 8 species. Decrease of grasses also increased. We started with 15.2 in 2019 and 32% in 2024, which is more than double. So we were happy to see that. And because we all know the decreases grasses is the ones that you really want to see increase, because they also provide higher quality grazing. And they determine, to a large extent, your grazing capacity is determined by the number of the decreaser grasses. The number of decreaser grass species also increased from in a 5-year study period. The increaser 3 grasses, those are the ones that you really want to see decrease, but they have decreased, but really much less than we have hoped for. So we started with 33% decreaser species, and we ended after 5 years with 29%. So that's really not a big change. However, if you look at those grasses in the field, you can see they have heavily impacted by the trampling. They are to a certain degree grazed, but because they're so unpalatable, even under ultra-high density grazing, the animals really try to avoid them. So we just hope, if you look in the field, you'll see they heavily trample. The seed production are heavily impacted as well. They don't produce a lot of seed. So I do believe they will further decrease in number over time, but we'll have to see. And then, interesting enough, a certain group, if we look at the growth form of the grasses, whether in the composition, palatable tufted grasses which has also rhizomes. So these are not lawn grasses or creeping grasses. They are, let's say, prostrate or intermediate type of grasses. They were the group of all the grasses that increased the most. They increased the most. So it does seem that high density grazing or ultra high density grazing benefits this group of grasses the most. Tufted grasses, which also have rhizomes. So it's not like a lawn formation yet, but something in between. Total number of grass species recorded also increased a bit. And what the grasses that decreased probably the most was your smaller sized grasses. And that makes sense, because what happened with the ultra high density grazing is you stimulate a lot of biomass. So and your small sized grasses are then outcompeted by your taller grasses with a high level of biomass. Climax grasses also increased a bit from, let's say, 60% to 68%. I was a bit surprised. Initially, I thought high density grazing, especially with the high levels of trampling will increase your pioneer grasses and subclimax grasses, but I was surprised that your climax grasses actually increased. And it's most likely connected to that 1-year resting period that follows heavy grazing. And your climax grasses can then recover and outcompete your smaller grasses like your pioneers, which are usually smaller than climax grasses. And then if we do the calculations to determine the veld condition score, especially the grazing value, using grazing value as within your calculations of veld condition score, it did increase from 43% to 53%, which is maybe not fireworks, but there is at least an increase in the overall veld condition score percentage. So if we look at the photos on the right hand of this slide, the top grass there is Festuca longipes, Candelabrum fescue, and this grass, the first surveys we haven't even seen this grass. Second surveys we've seen this grass, but we've never recorded the grass at one of our survey sites or sample sites. And then later on, we start picking up this grass within the surveys as well. So everybody was surprised. It was my first time that I ever saw this grass. And it is also, of course, a C3 grass, like all other festucas. And it's just an example of those C3 grasses that are reappearing almost and increasing in number over time. Where they're going to settle over the long run will be interesting. And then the remainder of those grass photos there, Digitaria tricolinoides, Setaria nigrorostris, and Andropogon peniculatus. Those are examples of grasses, palatable tufted grasses, which also produce rhizomes. So that represents a group of decreaser or overall grasses that increase, palatable grasses that increase the most within the 5 years. All right, so that was changes within the grass species composition, where we've analyzed various different guilds and groups to see which ones changed the most. So, of course, we can go into further detail there, but those were the most significant results that we've recorded in that 5-year time. All right, and if we then compare the non-selective grazing sites with the selective grazing sites, and I can just again mention that these are two extremes, because at Danie non-selective grazing, it's really at a very high density of non-selective grazing, and the control or the other site is really a good example of how you should not graze, and which leads to high levels of selective grazing. So that might also be the reason why we do see changes. In other areas, maybe drier areas, you won't see significant changes like this. In areas where it's not exactly two extremes, let's say just high density grazing versus rotational grazing, you're not going to see these extremes. But in this case, I would say even that we are fortunate that we have two extremes which will highlight the changes in a slow and shorter space of time, and also a better contrast between these changes. So large tufted palatable grasses with rhizomes, that's a group that really increased in the non-selective grazing sites. We're 41.8% at non-selective grazing sites on average, and then at the selective grazing sites only 0.5%. So that's quite a big contrast. And then your short creeping lawn grasses, of which Cynodon and Setaria facilitator variety torta were the two most common grasses there. Were quite low at the non-selective grazing sites at the end of the study period, at only, let's say, 4%, and then quite high, almost more than a quarter at the selective grazing sites. So as I mentioned earlier on, that 3.8% is probably low like that because of the high biomass produced, which would outcompete these relatively small lawn grasses. And at the selective grazing sites, they are actually quite maintained, and we all know these lawn grasses like continuous grazing, and they are very well adapted to continuous grazing because they can store a lot of reserve nutrients within the rhizomes and other parts, and they're not really that much affected by continuous grazing or short cycles of grazing because of that. Right, if we look at the forbs and focus more on the indigenous legumes, the legumes were 8.5% of the overall forb composition at the non-selective grazing sites, and 1.6 in on average at the selective grazing sites. The number of species of indigenous legumes were also more or higher at the non-selective grazing sites at 9 species recorded for all 4 sites combined, and then at the selective grazing sites 4 legume species recorded at those sites. Decreaser grasses, as we've seen on the previous slide, 32% for the non-selective grazing sites. And at the selective grazing sites, there were 10% decreaser species. Most of those decreaser species were Themida triandra that hides within the pockets of Aristida junkiformis. But still, there were at least 6 species recorded at the selective grazing sites, as opposed to a number of 14 species, decreaser species, at the non-selective grazing sites. So that's quite a high difference, more than twice the number of species at the non-selective grazing sites. Interesting enough, the increaser 3 species were still higher at the non-selective grazing sites at 22.6%, versus 19% of increaser 3s at the selective grazing sites. That 19% was all Aristida junkiformis. So what the reason for that higher number or composition of increaser 3 species at the non-selective grazing sites is, I'm not sure, but I suspect that from the start, from that Danie started with non-selective grazing, most likely there was already more increaser species present there, and they're just very persistent and highly competitive, and they don't change that easy. And the ones that's again also mainly Aristida junkiformis, and it just shows you how difficult it is to get rid of Aristida junkiformis once it is in your composition. They are really very persistent grasses and not that easy to get rid of them. Climax grasses were at 67.9 or 68%, and at the non-selective grazing sites, and 25, a relatively low 25% at the selective grazing sites. So once again, I was surprised that climax grasses increases, and I thought in the beginning, I certainly thought in the beginning that high-density grazing will lead to less climax grasses, but I was surprised to see that the climax grasses, specifically in this high rainfall regions, maybe in dry regions that might not be the case, and high-density grazing might lead to more pioneer and subclimax species, especially in the beginning. So yeah, that was a bit of a surprise. Right, and then if we look at the biomass production, production kilogram dry matter per hectare at the non-selective grazing site on average was 4.166 tons per hectare, and at the selective grazing sites it was 2.2 tons per hectare about. So that's just under half the biomass production at the selective grazing site. If you convert this to kilogram per millimeter rain received, and that was 450 millimeters received up to the time that we did our surveys, then you get 9.3 kilograms per millimeter rain at non-selective grazing sites and 4.8 kilograms of biomass per millimeter at the selective grazing sites. If we look at the water infiltration capacity, on average, it took 5 minutes and 31 seconds for 25 millimeters on average to infiltrate into the soil at the non-selective grazing sites, and it took 13 minutes and 11 seconds at the selective grazing sites for 25 millimeters to infiltrate into the ground. Grazing capacity, if we use the biomass method, was 3 hectares per livestock unit at the non-selective grazing sites and 6.2 at the selective grazing sites. And if you consider that at the non-selective grazing site, the stocking rate was 1.2 hectares per livestock unit versus 4 at the selective grazing site, that makes it even more remarkable that you can improve your grazing capacity over time with more animals is quite amazing. If we look at the overall botanical diversity, the number of herbaceous species, that's grasses and forbs, been collected or recorded at the non-selective grazing sites were 133, and at the selective grazing sites 96, which is still quite high. It's not that bad. All right, and if we run the species composition through the two diversity index methods, then on average, the index value for non-selective grazing sites on average was 12.2, a value of 12.2 and 7.6. So there is quite a bit of a difference in the diversity index values as well. Right, and I think that is my last slide. Yeah, just a bit of a visual, the results visually, 50% more good grazing grasses in 5 years. So that is quite remarkable to change your decreaser or good grazing grasses within 5 years, 50%. I think that's not too bad. And once again, if you've done that at lower densities, I don't think you would have reached that in 5 years so quickly. So once again, I think the ultra-high density grazing at those 5,000 animals per hectare density is probably a secret here. It's not everywhere where you can do it because of biomass available for animals to graze. But I think we're fortunate that we had a farmer who are willing to do ultra-high density grazing just to show us what can be done in 5 years. 50% more grass biomass compared to selective grazing. More than double the rainfall infiltration, and I think that's probably the secret of these changes. Certainly if it comes to biomass production, because obviously the more infiltration you get, the more biomass you can obtain. Obviously, the soil and soil health will also play a role there. 80% more indigenous legumes at the non-selective grazing sites compared to selective grazing sites. 60% higher botanical diversity, and more than double the grazing capacity at 3 times the stocking rate. So that more or less tells a story that's going on here. So I think in conclusion, this study demonstrates that adhering to the ecological principles based on historical migratory grazing patterns has the potential to significantly enhance condition of rangelands, improving grazing quality and quantity, as well as botanical diversity and water infiltration, specifically in the grassland biome of South Africa, where the study was conducted. So it is good results, and we're delighted to obtain these results. It's not going to say it's going to be everywhere in all environmental regions that you're going to obtain these results, and part of these good results is to have the two extremes next to each other, which highlighted the differences between the two extreme grazing management approaches. So high rainfall areas, you can apply ultra-high density grazing, and which will give you, due to the ultra-high density grazing and the herd impact, which will give you quicker results than lower densities or changes over time. And having the two extremes next to each other is certainly for the study a big advantage as well. Thank you very much. Yeah, so I just want to acknowledge our farmer Danie Slabbert and his family, who initiated this project, and for his support. He was with all the surveys. He's there, and he assists, and you can just see his passion for rangeland ecology. He has a huge interest and a passion for what's going on and all the details. He knows his grasses, he knows all those different grasses, and he was involved in everything. And I think without that passion and that support, that makes a big difference. And then Landbouweekblad, especially editor Chris Burgess, who played a very important role and provide funding as well. Jerry Weber from Green Bio also provide his support. And then I would like to thank Dr. Hendrik Smith and Gerry Treidsman. They co-initiated the project. They supported, and financially, even in the beginning, they supported the project, and they continued interest in support within this project. So I would like to thank them. All right, so thank you very much. That is the end of this presentation. I'm going to stop screen sharing.
Frits, you can keep it open, I think, while we're looking for questions. Yes.
Okay,
Thank you very much for that very insightful presentation. I'm sure everyone is surprised by just how big the impact or the difference is compared with the reference site. And, you know, just judging by the number of people we have attending today, this is a very topical aspect that we're discussing now. And you'll also see that we've got lots of questions already. So there's a few questions that were popped into the Q&A box, Frits. So if you can maybe just glance through that, and then we can open the floor. So Teresa turned off the mic, or you're able to unmute yourself. So you can raise your hand and ask a question, but let's just start at least with the questions that have been banked in the Q&A box already. Thank you, Frits. Can you see them?
I'm just going, it's loading now. All right, all of them, the top ones. I'm just scrolling through them. Teresa, Chrisette, at what? Teresa, did you also ask questions?
So she was copying questions from the chat box into the Q&A so that we don't lose track of them.
All right. So the top question I have here was that, that's the last question, I suppose. Should I go right down to the bottom for the first questions?
Yes, I think that makes sense. Just run through them, but then I think we can open the floor for live questions because that will also be valuable.
Okay, so there was first question, Teresa, what season were the photos taken? So there are various photos at various seasons, but most of our surveys we did around about February. And so that we tried, because of time restrictions, we need to collect data when the forbs are still visible and the grasses can be identified as well, and there's already some biomass. So it's not always that easy. Forbs and grasses are taking turn when they're going to flower, and so first flowering in the grassland starts with the forbs. They can even start in December and November, and then slowly the grasses overtake them. So our surveys, there were surveys done from 2019. Most of them were done in February. So, and then there's a second question: what animal production variables were measured? We haven't access to any animal production variables, calving rate, conception rate, but what I can just recall what I've heard during our discussions, that animals in the beginning, while they were still adapting and maybe the quality of grazing was still low, and we haven't seen the changes that we've seen later on in terms of your decrease or palatable grasses increasing over time. Animals did certainly take a knock, but over time animals adapted, and through selection as well. And due to the grass species composition improving over time in terms of quality, and probably soil health played an important role, animal condition improved. And I think in the beginning, our animal management in terms of supplement feeding and maybe providing peg and things like that were not on to scratch. And later on, people realize they need to feed the animals and they need to support them so that they can. And we all know during high density grazing, the quality of intake declines, and you need to manage that. And I think the farmer over time adapted and improved from that aspect as well. So in the beginning, there were school lessons to learn. Conception was lower. Animal selection took place. Supplement feeding in terms of managing condition of animals increased, and at the moment there's high conception rates, but it wasn't always like that. So and then next question here from Peter Hemming: was the croplands and additional food included in the study as a possible factor making high density grazing possible? No, this the study only focused on rangeland and certain rangeland parameters, grass species composition, biomass, forbs, and so on. So croplands and additional food like cover crops is not included in the study. And then there is what edaphic factors, if any, were measured. Yeah, so we haven't done anything on soils so far, but from next year onwards, we're going to include soils, and the whole idea is to two factors there. We want to take or collect soil data to see how homogeneous each of our transects are from meter 1 to meter 100. So we want to collect samples along these transects to see how the soil differs within each transect. And then we want to take soil samples just to do also a basic analysis, just look at the minerals organic carbon content, and those things. And then we also want to take samples to look at soil health, maybe Hanny's test or a couple of other tests that we want to run and look at the soil health status as well. So that's not included at the moment, but we are planning to include it in future studies. All right, and then there's a question. My view is that the grazing approach is often not about the system, but dependent on the rainfall and duration of rest. I think 1 month's rest is too short. 1 year rest is better, but will depend on the rainfall. Yeah, of course. I think this study also highlights that one month rest is definitely too short. Of course, it is connected to density as well. You know, if you have very low animal densities, low animal grazing impact, 1 month at very low densities might be enough. But even on the grazing capacity norm, in this case of 4 hectares per livestock unit, definitely 1 month is not enough. And the higher the density, the longer the rest period should be. So that should be balanced out. So a very high density, like in this case, you probably need 1 year rest. If you have lowest, you can make that rest period a little bit shorter. So there's definitely a connection between the intensity of grazing and the resting period, suitable resting period afterwards. So, and the rainfall does play a role. So the more biomass there is, the more intense grazing you can apply. There are, I suppose, certain cases where there's heavy degradation. You want to use high density grazing as a treatment, a restoration treatment, to break soil crusts and maybe bring seed in from outside into camps and improve soil fertility and so on through accumulating dung and urine. For restoration purposes, but then you need to supply fodder for those animals, roughage, and even maybe more quality supplements just for those animals to survive while you are using high density grazing as a treatment. So that can be done, but you need to supply them with food if it's not there. The question above about the animal production is very important. Yeah, unfortunately, we don't have. I must admit, it's not easy to get animal production figures from farmers. It's really quite a challenge. Some farmers freely share. Some farmers keep it close to themselves. So that is a challenge to get good quality data if it comes to animal production. All right, and then following question, how would fire change the result, especially late winter burn? With the removal of material and subsequent increase in soil temperatures, we might see a different outcome. Yeah, that's one thing for this particular study is we were lucky. No fires occurred from 2017 when the farmer started. Danie started with ultra-high density grazing. It will influence, it might set you back. However, with high density grazing and that long period of rest, all the reserve nutrients are already stored in the soil. And it's probably not going to impact, I'm not talking about annual fires, but if it's an occasional fire, it's most likely not going to impact the grasses that much. But as you mentioned, you might get more, it might impact your infiltration rate, water infiltration rate, which will subsequently negatively impact how much biomass you can get. The fire might impact slightly microbes in the soil as well. We know that fire can cause capping on the soil, so more runoff might likely, for a short period of time at least, negatively impact our results. But I don't think it will. It's not a disaster if you have the occasional fire. And then the next question there is the results of the 2024 status comparison of these two methods are very valuable. Do you know what the change was because of these trials? Trials comparison between before trial VS. Don't know what the VS stands for, after trial, to show changes in impact against the original status. Yeah, so there's some that I haven't showed, but the selective grazing sites, there wasn't much change over time in grass species composition. And there were quite a bit of changes in the non-selective grazing sites over time in the grass species composition in all ways that you analyze, all groups that you would look at. So there were definitely more changes over time with non-selective grazing versus selective grazing. Can't remember exact figures, but there were certainly more changes at the non-selective grazing sites compared to selective grazing sites. Was the infiltration measured in the field or in the laboratory? No, definitely in the field. Those were all field infiltrations. The 10% increase in Veld condition score, how did this translate to stocking rate for the farmer and financial benefit versus intensive grazing? Yeah, 10% increase in Veld condition score means basically your quality and quantity grazing, especially quality grazing, has increased. So it will reflect in animal condition over time. And I don't have figures, but it will reflect in your animal condition at the end of the time, because Veld condition represents mainly quality grazing, more nutrients in your veld. So that 10% is not a lot, but it will make a bit of a difference. In your view, could a lower intensity, high density grazing approach have achieved this remarkable outcomes, maybe 500 LSUs per hectare? No, I don't think it will. Your density, and as I mentioned, I think one of the reasons why we got such good results in a relatively short space of time is the density. It was probably not easy in the beginning, and there was some endurance that I'm sure was needed to continue with this high density grazing system. It's not always easy, but certainly I don't think 500 LSUs per hectare would have given us the same results in the same period of time. All right, and then at what density do you believe a farmer moves from selective to unselective grazing? Several intensive grazing models are used. Yeah, I think so this is connected to non-selective grazing, and as I mentioned before, there isn't something like non-selective grazing. Even at these, and you might have seen some of those photos, even at this very high stocking density, there was still a level of selective grazing, because some of those grasses in the sour veld is simply so unpalatable that animals can't eat them. And there are two particular grasses I want to highlight at this study. It was, once again, Aristida junkiformis. It's just a lot of fiber, a lot of cellulose, lignin, all those bad things. And animals did nibble on it. And then there's another one. It is Symbopogon deterleni. Symbopogon deterleni is a very big tufted grass. All the Symbopogons, have those terpenoids in them, so they're very bitter and unpalatable, and animals don't get anything from it. In fact, it's highly bitter and unpalatable. So although they do nibble on it, and they do trample it, and which is a good thing, because I think it's the only way we're going to get rid of Aristida jonquiformis is through trampling. Although it still takes short, but at least I think there's one way that we can get rid of this terrible grass is through trampling. So at what density? So people are talking about, and of course it's a gradient. So, if you connect ultra high with high density, there's a gradient. So at what density you're going to have impact, the non-selective level of non-selective grazing will, of course, increase the higher the density is. There isn't a cutting point where you can say this is ultra high and this is just high, because it's a gradient. So obviously, the higher you go, the higher the level of non-selective grazing would be. People are talking about 200 animals per hectare or 250 as the cutting point between selective or let's say high density grazing and let's say conventional grazing. But yeah, it remains a gradient, and maybe let's say 200 LSUs per hectare. Let's say there is the cutting point, but it is a gradient. Practical economic advice for how to transform a camp in the Highveld, which is dominated by bankrupt bush with little edible plant material, to a functional rangeland. Yeah, so the study also showed us that bankrupt bush, or slangbos as they call it there, is very sensitive to trampling. And we can just see, I haven't included photos here, but you can just see the trampling. It's a very brittle plant. It can't handle the trampling, and it completely disappeared. There are still here and there some bankrupt bushes remaining. There were quite a lot of bankrupt bush, but it was trampled. If you trample it 3 times, 3 years in a time, it's gone. And we could see how grasses start to emerge in the areas where previously where bankrupt bush was growing. We could even see how palatable grasses grow in trampled tufts of Cymbopogon. So bankrupt bush, definitely high density grazing is a method of controlling bankrupt bush. So practical economic advice, how to transform a camp in the Highveld dominated. My practical economic advice would be use high density grazing. Thank you for good. Not sure if I missed it. Was the palatability of forbs looked in as well? No, palatability forbs were, I would say, if it comes to palatability of forbs, maybe the indigenous legumes represent the palatability part of forbs. We couldn't observe any forb which is genuinely focused on for grazing purposes. But we could see under ultra-high density grazing, forbs are eaten and they are utilized. And what's interesting, the legumes, of course, put a lot of emphasis on indigenous legumes because they provide that extra protein. And so they are eaten. Of course, some legumes are high in tannins and so on, which make them bitter and unpalatable, and other anti-quality factors as well, of course. But they are eaten. And interesting, if you group the legumes as according to their growth form, it's mainly the trailing legumes, the climbing legumes, which are increasing in the non-selective grazing sites. And I think it's because of all the biomass at the non-selective sites. Your trailing legumes actually are the only ones that can compete to the bigger grasses by growing onto these grasses and still have exposure to sunlight for photosynthesis. So certainly that group of legumes have increased by far the most. But we haven't done any work on which forbs are preferred by grazers. Generally, we think forbs are not really playing an important role if it comes to grazing or offer any fodder or forage to animals, and that they more contribute to insect diversity and the pollinators and so on. But during high-density grazing, they are certainly eaten, and but we don't know exactly, which ones are palatable and which ones not. They are more or less to the same degree grazed under non-selective grazing. All right. Not sure that stocking rate coupled with the right type of animal is major indicator of farm profitability. Are you at the same point going to? Yeah, we haven't looked at the economic part in the study. So we just argued that the better the grazing capacity of the farm, the more economic advantages there would be to the farmer. So in other words, the better the ecology functions and soil health and diversity, that will good soil health and good ecological functions and processes will benefit the farmer because of increased quality and quantity fodder, which at the end will reflect in the profitability of the farmer, and vice versa. The more degradation and deterioration there is on the rangeland, and the weaker the ecological functions, will, on the other hand, also reflect in, let's say, less profitable farming. So, but we haven't made the connection to prove, yes, it is. This farmer's veld is improving over time. His grazing capacity is improving. Everything is improving. And also his finances is improving over time. So we haven't made that connection. We just assumed that when the veld is in a better condition and grazing capacity of the veld is improving over time, it will reflect in the economics as well. So I'm sure that is true, but I can't prove that to you. All right, I think it looks like we've gone through all the questions. I hope I haven't missed any, and maybe new ones came in.
Yeah, I'm wondering if we should open the floor. If there's anyone with a question, I see Gustav has one. Gustav, you're welcome to unmute yourself and go for it. Thank you.
Thanks, Frits. Thanks for such a good talk and for all the information. It's really great. I just wanted to find out what's your opinion on. I realize that holistic management are against fire. But in the case of the patches of Aristida and that Limpopo species, don't you think fire can fight together with the grazing interaction can, when it's still young, very young, the Aristida after the burn, so the grazing glaze and graze theory. So I know holistic management is against fire, but only for those sections to try and encourage and improve the palatability of those desirable spider and the Limpopo.
Yeah, thanks for the question, Gus. So, yeah, fire, those grasses, the Limpopo as well as Aristida, just like fire. So you can just hear if fire goes through the veld, and those are common in the veld. So, and they regrow very well after fire, and they are certainly palatable after fire for a month or two, and you do get a bit of a lower level of selective grazing after fire, but later on it just equals out again, and selective grazing continues, harming the good grazing grasses. So my opinion is using fire to try and get rid of Aristida junkiformis and other C3 grasses is not successful, and it doesn't change the grass species composition in favor of your good grazing grasses, and that it is to a large extent a little bit treating of symptoms of historic overgrazing, and you're not going to change it. You're just treating those symptoms, and it's not going to change the grass species composition in favor of your good grazing grasses. So that's my personal opinion, and I don't believe fire will improve the veld and the grass species composition over time.
So the crawling at night in those patches with Aristida and Symbopogon.
Crawling, I haven't seen any results of short-term crawling on those areas. I mean, normally those areas are so big, you're gonna need those huge crawls. But no, I haven't. But I do believe crawling will change it. Whether it's going to change it with one single crawling event, I doubt it. All right, there's a couple of hands, Elian.
Yes, next one up is John. Thank you, John.
Hi, and thank you for taking my question. I live in the Midlands of KwaZulu-Natal, where the rainfall is in excess of 1,000 millimeters per annum. The soils are therefore very leached, and I'm interested to know what your view would be in this with this kind of grazing work in those kind of mist-belt grasslands. I note at the beginning you talked about, and I think I'm correct in talking about simulating the previous wildlife grazing capacity or grazing animals. This is not the case where in the Midlands, because Midlands mist-belt grassland, because large animals were not present there in historical times. So I'm just wondering whether you could cast an opinion on very, very sour veld grasslands, 1,000 millimeters and above, whether you would expect to get any changes along the lines you have suggested. Thank you.
Yeah, thanks for that question, John. Yeah, I'm aware that there are areas, regions where historic migrations were not present, and I would assume, as you said, those are highly leach out soils, and but honestly, I don't have any experience or even visually observe those areas, and to what extent high density grazing might improve grazing conditions or even soil conditions. I know those sandy soils don't keep a lot of organic carbon either, so it might be difficult increasing the health of those soils. It might take much longer. But yeah, unfortunately, I really don't know what the impact of high density grazing would be. And I wonder if there are farmers who have at least tried high density grazing in those areas and have they experienced any positive impacts resulting from that. But I really I don't have I have little experience in those regions. Maybe somebody else in here can maybe provide us with a bit of information.
I'm also thinking we should reach out to the farmers networks because there's got to be someone in that region who has tried it. There's a couple of farmers on the call who do high-density grazing, so maybe it's just a question of phoning a friend or getting him connected to the right person. John, so we'll make a note of that. Then the next question is by Richard Finn. Thank you, Richard.
Hi, Frits. Thanks for an interesting talk. And I think the high-density grazing is great to really get the non-selective grazing. I think that's a critical point that we need to address, getting non-selective grazing. But it's not the only way you can. Well, you can. I still believe you use the high-density grazing, but where I see in your high rainfall areas where you're in Southveld, where there's a I see a flaw in this approach is that while we know it's not simulating what everyone likes to claim, that it's simulating how wild herbivores, these big migratory herds of wild herbivores forage, and it's not at all, because your big migratory herds like the wildebeest, they always came back to regraze the regrowth of your grassland, because that's the high quality. So they wouldn't just go like you're doing with your cattle here, put them into tall grassland that's been resting for a year or whatever, and then eat it down and then move on and continue eating tall grass. They never do that. They come back to eat the regrowth after a few weeks, because that's where the high quality is. Otherwise, the population would go extinct. So that's why your animal performance also dropped so terribly when you started this approach. And then you're having to feed your animals now a huge amount of supplements to try and get their conception rates up and everything, which in my opinion is also now a problem for the economics of the farm. So this can be simply addressed by just changing the way you're doing your high density grazing. You have your priority areas that you say, this part of the farm this year we're going to keep it short through high density grazing, but you can use a fire in the beginning of the season, or you graze it down during the dry season, get everything short. Then you put the animals in at high density and you keep it short. Soon they graze off that area, they move to the next area, but you're always watching those first paddocks that you left a few weeks ago. As soon as the regrowth is ready, you bring the cattle back and you use that regrowth. And this is where you can deal with your Aristida jansiformis. If you get it down through fire or through heavy trampling over the dry season, whatever you want to use, if you don't want to use fire, when you keep it short, we do have data that it doesn't like it. So I have experimental data that I've used, that I've published. We did experiments where we non-selectively clipped Aristida jansiformis growing with Themeda triandra, and the Themeda triandra just wipes it out in a very short time under that approach. But when you're trying to allow it to grow out and to grow tall, then the animals won't eat it. So when you keep it short through this priority approach of coming back to keep those areas short through grazing the regrowth, then the Themeda just wipes out those grasses. So I see Danie's approach here can be dramatically improved by just changing a few things. You need to come back and use the regrowth. I see you do that with your heifers, or I think it was the calves or the heifers. I bet you those heifers are doing a lot better than the cows, because they're coming back a month later, and that's still a bit late. 6 weeks later, it's too late. You need to come back within a few weeks so that grass is only a few 10 centimeters to 15 centimeters max high. And then that quality is acceptable. You don't want it, especially in Southveld, probably 10 centimeters as high as you wanted to get, because otherwise they won't eat the Aristida after that. So I like your approach, but I really do believe this approach needs to be fine-tuned, and that for the Southveld, the higher rainfall you go, the more you have to keep that grass short and the quality high. So yeah, just some things to think about here. And I really think Danie needs to consider this. He won't have to now add as many supplements. He'll get much better animal performance, and I believe the veld condition will actually get better. You'll push out those Aristidas and things much quicker. So that's just something to say. We have data for it as well. So just something to say there.
Yeah, thanks, Richard. Yeah, I agree, and that's exactly the reason why the heifers are now following. I said I think they follow after 1 month. I can't remember exactly, might even be less. But And I think Danie also realized that, you know, having animals eating low quality grazing all the time is not a good thing for condition. And yeah, it will be interesting since he started with that, I think 2 years ago, it will be interesting to see how it influences our data, because we're going to start seeing that effect of the second rotation going through now as well. And but I still think the ultra high density grazing in the beginning, especially and combining with a long rest, also played a role in improving the grass composition and the soil over time. So yeah, I think there might be a time where you have sort of a, let's say, restoration period with high impact, and then lower on starting using the results of that to improve your animal condition.
But yeah, so it's not using the high density is great. I'm not saying anything about the high density is excellent. The higher the density you can graze, the better. That's not the problem. You don't change that at all. You just change the way you're doing it with coming back. And then those areas that you do regraze that year, your areas that you keep short, then the next year you take them out of the system, because you've grazed them pretty heavily you've kept them short for the whole growing season. The next year you must give it a full year's rest. So it's just a slight tweaking of the system that I'm saying could really improve not only the grass but also your animal performance. You're still using ultra high density grazing. You're just changing the pattern a bit. Yeah.
No, I agree. Having 2 blocks and, you know, using one on 2-year rotation with high density rotation and resting one alternately, that's definitely a good idea.
So Frits, we've got 2 more questions, one by Peter and one by Urapeleng, but we're unfortunately out of time. So I don't know, we still have lots of people in the room. If they're willing to wait, we can take one more question, but otherwise I think we should close. But what we have seen now is that there's enormous interest in this topic, and I think there's grounds for having a follow-on discussion from this, just because there's been so many high-quality questions. And, you know, you can also come to us with suggestions for titles for follow-up web chats on this, if this is a topic that you are interested in. So that's also a way to deal with that. And Frits, I don't know if you're open to receiving questions from the audience, I don't know, by email.
Yeah.
If that's an option.
Yeah, no, people can email me. And definitely they can email, and then I'll answer the questions. I don't always have a lot of time, but I'll try my best to do it as soon as possible. Yeah.
Okay. Do you want to take one more, or should we close now?
Let's take Peter Bota's question.
Perfect. Thank you, Frits.
Morning, Frits. Thank you very much for the presentation. I just wanted to ask 3 short little questions which I haven't picked up here in the data that you presented. How has the basal cover or the percentage of cover differed between the high density grazing areas and the selective grazing areas? Did you at some stage possibly look at vigor between the 2 systems as well? And then how did they affect watering for the animals in the high density grazing in those strips? Did they move a water trough with that system every day, or were the animals forced to only take water in the evenings after the days run out? Thanks a lot.
Thanks, Peter. Yeah, we haven't actually measured basal cover. But the basal cover at the selective grazing sites were very good because of the grazing lawns present in those areas. And then at the non-selective grazing sites dominated by tufted grasses, the basal cover was not as good, but there was a lot of mulching and litter and so on right at ground level. So if you consider that, of course, then the basal cover was excellent or very good at both sides. The water question in the beginning, water was at the end of each of those strips, so animals will graze and go back within the same strip go and drink water. Later on, the water was a more mobile watering trough system was developed. So the water will follow the animals, not too far behind them within the same strip. I can't remember the second question.
Sorry, it was pertaining to vigor between the two setups as well in your grasses in those sites, well, plants in general.
Yeah. Yeah, we haven't measured vigor. So for vigor, you would need to go back, let's say a month afterwards and see how much regrowth you got. So, and the other system, you can't really measure vigor because, well, I suppose you can a month later on, but the research studies, you're bound to, you have a week or two and you need to do your surveys. You can't really come back. So we haven't measured regrowth.
Okay, thanks for that, everyone. And Frits, thank you again for being willing to share your expertise with us and this good news story. Isn't it a very good news story? Teresa will share an email later with a link to the recording as well as the presentation. And I hope to see you again soon at one of our web chats. If you're coming from the agricultural sector and you're not a member of LaRSSA, just sign up to the mailing list because we host regular web chats once a month, and it's got an agricultural focus as well. So there will be some more chats coming up that will be of interest. Thank you, everybody, for your attendance. See you next month. I'm going to close the meeting now.
Okay, I also just want to say thanks for everybody that tuned into us, and we really appreciate it. And thank you and go well.
Perfect. Bye, everyone.
Thank you. Bye.